Does the tie go under the jersey or over the jersey? It's been a long time since I played.
Everybody get up, it's time to slam now. We got the real jam going down. Welcome to the Space Jam. Here's your chance, do your dance at the Space Jam. Alright.
Wait, where did he go? Oh, I guess that's his thing. What is up, Glenwood Middle School? How are you guys doing today? I'm having a wonderful day. Thank you for asking. Nobody asked, but no one's here. So it's Mr. Curry talking to himself. All good. Anyways, tomorrow you guys have your end module test. It is over translations, reflections, rotations, parallel lines, and stuff like that. We are going to go over a quick review of some things that I think might trip you up tomorrow. So pay attention. And this is a good thing to study tonight. So, one of the first questions on your test is asking about rectangles, rhombuses, squares, and parallelograms. And so we're going to define those. A rectangle has 4 90-degree angles. And that is all a rectangle is. So if a rectangle has the same area, they could have different side lengths, right? And therefore they would not be congruent. A rhombus has 4 sides that are the same. And a rhombus can either look like a square, or it can look like a diamond, like a kite. A square and a diamond are not congruent to each other, so just because you know one side of the rhombus doesn't mean that you know they are congruent. A square is like a rectangle and a rhombus put together. They have 4 equal sides and 4 equal angles. A parallelogram has 2 pairs of parallel sides. So 2 sets of parallel lines. Right, and a square is an example of a parallelogram. A rhombus is an example of a parallelogram, or a rectangle is all examples of parallelograms. Parallelogram is the least descriptive of the term. If you do know a side length of the square, though, you do know that those 2 squares are congruent because all side lengths are the same. Our next type of question would be, I have a figure and I'm going to give you a series of transformations, and I want to see if it lines up back in the same spot. So First one, let's reflect it over the line. And now we're here, right? And what if we reflected back over the line, right? If we reflect something 2 times over the same line, it stays the same, okay? So if we go back and forth, it's gonna stay the same. If we have a translation and we move them over here and then down and then over and then back, right? We've gone back to the original shape. So you can get back there with translations. If you rotate 360 degrees, right? Or a series of mini rotations that add up to 360 degrees, you've gone all the way around the circle and you're back at the starting point. So you should be able to describe a series of transformations. This one's a little tricky. So I have 2 different designs. If the designs are exactly the same as each other, then they are congruent. But if one part of it is different, they are not congruent. However, one thing you should notice is that this smaller star is congruent to this smaller star. So if a series of shapes is moved in relation to each other, they are no longer congruent, right? If I have a smiley face and I'm like, I want to draw another smiley face, and I put the eye under his tongue, right? Those shapes are no longer congruent, right? Even though they have all the same stuff, they're not the same shape, okay? Moving on. Next, we are going to have to describe a series of transformations to get from this shape to this shape. And I know they're not exactly equal, but pretend that they are. So I'll give you 30 seconds to think of a series of transformations to go from 1 to 2. 30 seconds on the clock. Pause the video if it's going to take you longer. All right, there are 2 transformations that we need to do because I said a sequence, right? A sequence means more than one. The first one I'm going to do is I'm going to reflect him across the line that's in the middle. Then I would have a shape that looks like this over here, right? Once I reflect that over this line. The last step would be to translate it down. A translation down is -y. So first step is reflect across the line, whatever this line is. And your second step would be to translate in the -y direction, however far this distance is. Okay? Should be able to describe a series of transformations that go from one object to another. All right. Are these 2 shapes congruent? And how do you know? The first one is, are they the same shape and everything? Like, do they look congruent to you? And in this case, kind of no, but I've tried to make them congruent. So pretend that they are, right? These 2 shapes are the same. How you would prove or explain congruence is you would tell me the transformations that it took you to get from 1 to 2. So if I reflect, that would be my first step. And now I'd have a triangle that's over here, right? And then the last step is, once again, I just translate this triangle down and a little over to the right to line up perfectly with that triangle. So the first step was a reflection. The second step was a translation. And because the figures lined up evenly, right, because they matched, that means that those 2 shapes are congruent. Does that make sense? Sweet. Moving on. We finally have our angles and lines equations. So one thing you need to know is if I have 2 angles that equal a straight line, those are going to add up to 180 degrees. And another thing you need to know is that all of the inside angles of a triangle add up to 180 degrees as well. So if I give you this angle here and that angle there, you should be able to tell me what all the angles are in the triangle. This angle is 160. So that makes this little angle over here 20. Oh no, move the line. All right, so this little angle over here, right, is 20 degrees. So we have 40 and a 20. We're going to plug those into an equation for a triangle, which is all three angles added together equals 180. We'll call that angle A. 40 plus 60, or 40 plus 20 is 60. And we're going to subtract 60 from both sides as our next step. 60s over here cancel. And we are left with A equals 130 degrees. So that angle is 40, that angle is 20, the other angle, oh my God, sorry, 120 degrees, Mr. Cartwright. 80 minus 60 is 120, not 130. Good job. So 120, 40, and 20 are our three angle measurements for that triangle. The other thing I wanted to point out is if we have these points E, D, and C, we would write the angle EDC like that. What's important to know is that the middle letter is always going to be the angle that you're talking about, right? So it's that one, right? It's the angle that's associated with D. Do we have any more? I think that was it. One more. So this is a square. And you know that in a square, every angle is 90 degrees. So if we added up all of these angles, oh my God, 4 90s, we would get 360 degrees. And that is true for any four-sided shape, any normal four-sided shape, like that one, right? The inside angles are going to add up to 360 degrees. There's a formula for this, but we don't want to talk about that right now. Anyways, triangles are 180. Squares, or quadrilaterals as they're more accurately called, would be 360 degrees. Thank you guys for paying attention, and I hope everything made sense. Please ask questions in the live classroom if you have any. And have a wonderful day.